Hi guys, welcome to the channel. So today the question we're trying to solve is detonate the maximum bombs. So what this question says that given an array of bombs, we need to find out that if we detonate any one of them, which bomb is going to cause the detonation of the maximum other number of bombs. So for example, in this case, there are two bombs. One is at uh, 0.2 comma 1 and the other is at 6 comma 1, and the radius of this point is 3. So if the bomb explodes at this position, the any other bomb within this radius, if present, will also get exploded. So in this case, if this bomb goes off, there's no other bomb within the radius, so nothing else will go off. But if we start with this bomb, and if this bomb goes off, this is going to create this bomb go off as well. So that is why the output here is 2. So this is what the question is. So how do we approach this question? Hmm. So the first basic thing that we need to take care of is how do we find out the distance between these 2 points? Because if you see that if the distance between the 2 points is actually within the radius of this point, that means as if this one goes off, this will also go off. So the formula to find out is basically the square root of x2 minus x1, or probably let me write it here. So the distance formula is square root of x2 minus x1 square plus y2 minus y1 square. So this is how we can find out the distance between 2 points. And so if this one is exploded, so the distance between this and this is going to be 4. And since this bomb is outside of that range, this will not get exploded. But the opposite is not true. So if this one gets exploded, this bomb is within the range of this explosion. So this will also get exploded. Right, so here is the formula x2 minus x1 square plus y2 minus y1 square is going to give you different distance between 2 points. So that is done. Now, what we can do is we can visualize this question as a graph. So if we can join as a directional graph but not a unidirectional graph or a bidirectional graph, this has to be a directional graph. So if we basically join 2 points which are connected to each other, it will be easier to find out when some point is explosion. When explosion happens at one point, the others are going to go off or not. For example, in this case, there's going to be an edge from this point to this point and not from this to this. The reason is this one goes off, this will not go off, but if this one explodes, this will definitely get exploded. So there has to be a edge from point B to point A. Let's consider one more example. This one is a bit bigger one. So in this case, if we visualize this as a graph, so the graph that comes out is going to be if 0 gets exploded, then what is within the range? 1 is within the range and 2 is within the range. So if 0 gets exploded, 1 or 2 can also get exploded, right? Now, if 1 gets exploded, but if you see in the output, the radius of 1 is 1, so so there's nothing within this range. But if you see here, this is the second point, so the radius is 2. So within, if this point gets exploded, so there are two more points which will get exploded. This is point 1 and point 3. So for 2 it is 1 and 3, and for point 1 there is nothing. For point 3, if this bomb gets exploded, if you see this range, so 1 and 2, oh, this is 3. 3 is this. So 1, 2, and 4, all of them will get exploded if 3 gets exploded. So for 3 it is 1, 2, and 4. Similarly for 4, if an explosion happens on 4, in that case only 2 and 3 are within the range of 4, because the radius is 4. 1, 2, 3, 4. So 2 and 3 are only within the range of 4. And how do we find this range? We find this with this formula. So what we need to do is, so for example, let's consider 4. The radius of this fourth point is 4. So the explosion radius is 4. So if I say 1, 2, 3, and 4, so up till this point, all the points which is in this range will get exploded. And can find out distance between 2 points using this formula. Right. So if we are able to create this graph, once this graph creation is done, it's pretty simple. We just need to try to explode at each point and then find out the maximum number of other bombs that can get exploded. For example, let's say we consider 1. So if an explosion happens at 1, no other bombs are going to get exploded, because at 1 there's no other bomb is in the range of 1. But suppose an explosion happens at 0, right? Now 1 and 2 are going to get exploded. If 1 gets exploded, nothing happens. But if 2 gets exploded, then 1 and 3 gets exploded. Well, 1 is already exploded, so we can ignore this. But yeah, 3 can get exploded. If 3 gets exploded, then 1 and 2 are already exploded. We can ignore this. 4 gets exploded, right? So, and if 4 gets exploded, 2 and 3. But 2 and 3 are also exploded. So in this case, if you see what number of bombs we covered 0, 1, 2, 3, and 4. So total number of 5 bombs. So the answer in this case is going to be 5, because this is the max number of bombs that can get exploded. So this is like overall uh, high level way to just solve this question. Now let's just try to get into the code. So what we can do is, first we need a graph, right? So this graph. So what we can do is, this can be some sort of an integer, but this can be a set, basically a set of indexes in this case. So 0 represents this bomb, 1 represents this one, 2, 3, 4, and so forth. So let's just say we have a graph, and let's try to iterate through the bombs. Now, since we need to do this calculation, let's just keep the values in separate variables to make it easy to read. Bombs at position I and 0. So this is X, this is Y, and this is actually the radius. So this X basically represents this, Y represents this, and R becomes the radius. So we would need another loop. So what we're going to do is, we're going to compare each point with each other point to find out, to create this graph. Now, so that one index is not compared with itself, we put this check. So the same indexes are not compared with each other unnecessarily. Now let's do the same thing and create other point. So let it be x2, y2, r2, and this is going to be j, j, j. Now once we have two different points, we need to find out this the distance between these 2 points, and that can be done using this formula. So how we can do it is, square root of math dot x2 minus x plus, I can just copy this, y2 minus y. This is the formula. Now the thing is that once we have the distance between these 2 points, and we need to create this graph. So if distance is less than equal to r, so suppose this is I and this is j. So right now we are trying to say if there is an edge that present is there between this and this point. So if this distance is smaller than or equal to r, then there should be a edge that should be there between this and this point. But in this case, this is not going to be true. Let's consider this example. So for this example, the r is 1, 2, 3, 4. So when this and this point is considered, and an explosion happens at this point, we have to have an edge between this to this point. So that is what this is. So graph at position I dot add j. Now we just need to initialize all the i's first as a set. So if graph as position I undefined, in that case we just need to create each point as a set before we try to add things to it. So yeah, this is it. So the graph creation is actually done. Yeah, now, so this creation is done. Now we just need to iterate by exploding at each index and try to find out what is the max depth. So let's say the max depth is set to 0, and we need to iterate through each index. One more thing is we need to keep track of what is already exploded. So suppose we are at 0, we explode 1 and 2. Now we go to 2. Now at index 2, we see that 1 is also getting exploded. But since it is already exploded, there's no need to recalculate 1. So we can directly calculate 2. So 3. So for that case, we'll have to create some sort of a set. So that should be a visited set. We can name it, and let's say math.max of whatever is the current depth, and let's create a function called max that takes in the index we're trying to and then the visited set, and also let's just push in the graph. And in the end, when this is done processing, we just return the depth. Now let's try to implement this function max. So this basically take 3 things: the bomb index, the visited set, and the graph itself. Okay. Now first let's just handle the break scenarios where we need to break the code. So if the bomb index becomes undefined, at that point we just return 0. If graph at that find our graph at that 0, then just return 1. So why this condition? So this condition because is suppose in this case, if suppose from 0 I go to 1 and from 1 I see that okay, there is nothing else that I can, there's no other bomb that can get exploded, so I'll just return 1, saying that okay, there's only one bomb that can get exploded here, which is 1. So that is what this condition is. And let's say let there be some output, the initial the final output. Now what we need to do is we need to just iterate through, for example, let's say we are at this 0th index, so we need to iterate through this list and do the same for 1 and then do the same for 2. So for const of graph bomb, what we can do is out is equal to out plus, I have to call this function again. I will pass in the new bomb, the visited set, and the graph. And finally, we just return out. One more thing to handle is the visited thing. So if visited dot has bomb, then we'll return 0, and visited dot add the bomb here. Yeah. So what we do here is basically, if we have seen that okay, this bomb has already been exploded, we just return 0 because there is no point to calculate that again. And if it is not, we just add it to the visited set. So in this case, suppose we can do one more try run. So once 0 get exploded, 1 will get exploded, it will come here and we will see that okay, there's nothing else that can explode it. It'll go back, then it will try to explode 2. With 2 it will come here, it will say 1 is already exploded, so it will try to explode 3. Now when it comes to 3, it will say 1 and 2 already exploded, cannot do anything, try to explode 4. And so in this case, 4 will return 1, 3 will return 2, then it will come 3, then this is going to return 4, and this is going to return 5. So the total depth is going to be 5. Because 0, 1, 2, 3, 4, all of them are exploded in the same recursion, in the same function. Yeah, so looks like it is done. Let's try to run this. Okay, there's something wrong. Let's see what is wrong. Output is 1, expected is 2. Okay, looks like this is missing. So math.power is basically, I missed this exponent. And this one spelling mistake here and here. Let's just run this now. Looks like this is working. Let's try to submit. Yeah, so it worked. So yeah, that's the solution.